band pass data transmission, all three modulation techniques are suffers with one common problem, which is nothing but the coherence, okay, synchronization. Now there is a mismatch of frequency and there is a mismatch of phase, then is a large deviations are taking place, okay, because of quadrature null effect and frequency shift key. So, and out of ASK, FSK, PSK, then we always prefer PSK. So, to overcome this coherence problem, a slight modification of PSK, okay. Now, the slight modification of PSK, which is nothing but this slight modification for overcome the problems what we are faced in the coherence, okay. Now, that slight modification of PSK, which is nothing but a differential phase shift keying signal or a DPSK signal, okay, DPSK modulation, differential phase shift keying, okay, DPSK. So, you know that what is a slight modification of PSK already I am saying. This is a PSK modulator, is generally a PSK signal, producing PSK signal. But we are doing a small change here, a differential encoder, followed by a differential encoder followed by PSK modulator. A differential encoder followed by PSK modulator. This is nothing but DPSK transmitter. This is nothing but DPSK transmitter. Now, this is nothing but DPSK signal, modulated signal, but followed by a differential encoder. So, this is nothing but DPSK signal. So, you know the differential encoding. Now, what is the differential encoding? How you can get? What is the differential encoding? I just recollect. What is the differential encoding? Differential encoding, binary 1 means previous level. Whatever may be the previous level, that previous level is continues. For binary 0, what is a binary 0? Whatever may be the previous level, that previous level is complemented. If it is 1, 0, 0, 1. Okay, this is a differential encoder. You know that an exclusive NOR gate with an appropriate feedback will be acting as a differential. It produces the differential encoding. Okay, all these things we are seeing the electrical representation of encoder output. Okay, so now we'll design a circuit. Now this is a binary data. Assume this is the reference level or a previous level. The reference level is 0 volts. I am giving. Okay, previous level is 0 volts. This is the reference level 0 volts. Okay. For binary 1, previous level. For binary 0 is previous level is complement. Now we will first designing a transmitter portion. What is the transmitter? Differential encoder means an exclusive NOR gate. An exclusive NOR gate with an appropriate feedback. An exclusive NOR gate with an appropriate feedback. An exclusive NOR gate with an appropriate feedback will be producing a differential encoding signal. Means, now this is the binary 1, previous level is low level. So, what is the binary 1? Previous level is continue, previous level is a low level, it will be continue. For binary 0, previous level is complemented, low level is complemented to high level. Binary 0, again previous level is complemented. Now binary 1, previous level is continue. Okay, previous level is continue like this. Okay, or we can consider, you can write one more thing also if you require. Binary 0. Now for binary 0, previous level is complement. Now this is the differential encoder output. Now see here, PSK modulation, PSK signal. PSK signal means just multiplied with the carrier, right? AC cos 2 pi FCT. But what is the problem we are facing? When carrier is multiplied, now this differential encoder output is nothing but an on-off signaling. This is on-off. See, on-off, on-off, on-off. But when on-off representation is multiplied with a carrier, it never get a PSK signal. It will get an on-off ASK signal. But I want a PSK signal. Therefore, this on-off must and should be converted to non-return to 0. Therefore, here we use a level shifter. What is that? Level shifter. The level shifter shifts the on-off signal to the level shifter shift the on-off representation to non-return to 0 representation. Means this 0 volts will become more negative, and this positive voltage will become more positive. Plus 5 becomes plus 10, 0 becomes minus 5 or minus 10, like this. This 0 volts will become more negative. This 5 volts will become more positive, like this. Now what I mean, this is on off. Now this is a non-return to 0 signaling scheme. Is it right or not? Because the non-return to 0 signaling scheme is required to generate a PSK signal, right? So now this level shifter output will be going to PSK modulator. Okay, this is a change in a PSK and DPSK changes. Okay. Now this is a carrier AC cos 2 pi FCT, which is nothing but AC cos 2 pi FCT plus AC cos 2 pi FCT minus. Definitely this is a PSK signal, but followed by a differential encoder. Therefore, this is called as DPSK modulated signal. DPSK modulated signal, and this is the DPSK transmitter portion. So I'll write here directly AC cos 2 pi FCT multiplied with minus. Therefore, this is minus AC cos 2 pi FCT. AC cos 2 pi FCT multiplied with minus. Therefore, minus AC cos 2 pi FCT. AC cos 2 pi FCT multiplied with plus AC cos 2 pi FCT. AC cos 2 pi FCT multiplied with minus AC cos 2 pi FCT. AC cos 2 pi FCT multiplied with minus AC cos 2 pi FCT. AC cos 2 pi FCT multiplied with plus AC cos 2 pi FCT. This is the, see here, minus plus at transitions. These are nothing but a phase shift keying signals. Now these are the phase shift keying signals. Now this is a DPSK transmitter portion. Okay. So now we'll see the receiver portion, but before that you just take this one. Okay. Now this is the DPSK transmitter portion. Now we'll construct the receiver portion. Okay. Now What is the input to the receiver? Is a DPSK signal. Again multiplier, again carrier, again local oscillator is nothing but what? Is nothing but a coherence. But we are not interested on the local oscillator at the receiver. I don't want a synchronization at the receiver. Therefore, you want to remove this particular part, okay? Without synchronization, I want. This is non-coherent. So again, I use the same multiplier, but the input to the multiplier is directly DPSK signal. And another input to the multiplier is same DSK signal, but is passing through a delay line. Now this delay line duration is TB, bit duration TB. Now this delay line duration is TB seconds, bit duration is TB. See here, what is the meaning of that? One is direct DPSK, another one is with a delay of TB seconds. So which means that now each bit is having a duration of TB seconds. Bit duration is important. That's what I am asking every time. You must and should write each bit is having a duration of TB seconds. Each bit is having a duration of TB seconds. Present and previous. Delay means this is minus into minus plus AC square by 2 plus cos. So that I can eliminate it with the help of low pass filter. Okay. So if I use the low pass filter will eliminate that high frequency component. What is the output of the low pass filter? See here. Minus into minus plus AC square by 2 plus cos 2 pi into 2fc, that is eliminated here. Now here plus into minus minus AC square by 2 minus into plus minus AC square by 2 minus into minus plus AC square by 2 plus into minus minus AC square by 2, and this is applied to a threshold comparator. You know the threshold comparator. Regenerative repeater is also acting as a threshold comparator. One input is this, and another input to the threshold comparator is threshold voltage. You know the threshold voltage. What is the threshold voltage in non-return to zero signaling scheme? This threshold voltage is 0. So the output of the low pass filter, now this voltage is compared with the threshold voltage, and threshold comparator will take a decision. Okay. Now you tell me AC square by 2. This is plus AC square by 2 positive voltage. Now when compared with threshold voltage, that voltage is greater than this threshold voltage, then it will be treated as binary 1. Then the signal strength is more than the threshold, treated as 1. The signal strength is less than the threshold, treated as 0. Next, so this is binary 1. Now this is threshold voltage. Now this signal strength is less than the threshold voltage, 0. Less than the threshold voltage, 0. More than the threshold voltage, 1. Less than the threshold voltage, 0. Right, like this. If this signal strength is more than the threshold, is greater than, so binary 1. The signal strength is the output of the low pass filter, that the strength is less than this threshold voltage, then the threshold comparator will treat it as a binary 0. So this is the output of the receiver, but what we are transmitted 1 0 0 1 0. What you are received 1 0 0 1 0. Say matching or not? Now you can successfully get back at the output of the receiver is the same binary data but without carrier. without local oscillator, without synchronization, without coherence. Okay. Now this is nothing but DPSK receiver portion. This is the DPSK receiver diagram and this is the DPSK transmitter diagram. This is the DPSK transmitter. So what should be the advantages of this DPSK? No local oscillator, no carrier at the receiver, no coherence, no synchronization, but you can get back the exact same information. Now what is the information? What is the binary data here? Now the binary data, which is nothing but here, what we are taking, the binary data is 1 0 0 1 0. Okay. Now this is the binary data which you are collecting, which you are transmitting, but what is the receiving here? Now the received is 1 0 0 1 0, same thing, the receive. Okay. Now but without carrier at the receiver, now without synchronization, without local oscillator. Okay, note down this. Differential phase shift keying, differential phase shift keying, DPSK. Now we just see a few points here. No local oscillator, no local oscillator at the receiver. So no carrier at the receiver. Therefore, no synchronization, no synchronization between transmitter and receiver. No synchronization between transmitter and receiver. No synchronization between transmitter and receiver. No local oscillator, no synchronization, no carrier at the receiver. Therefore, no quadrational effect, nothing. Therefore, this is non-coherent PSK. Am I right not? If all these are, local oscillator is there, carrier is there, synchronization there, that is nothing but PSK. But all these not there. Therefore, this is non-coherent PSK is nothing but DPSK. Understand or not? Now, differential phase shift keying signal is also called as non-coherent PSK. Okay. Now, here in binary 1 represented with a phase of binary 1 represented with a phase of 0 degrees, binary 0 represented with a phase of 180 degrees and 5 radians. Okay. So in DPSK, the binary 1 is represented with a phase of 0 and binary 1 is represented with a phase of 0 degrees. Binary 0 is represented with a phase of 180 degrees or 5 radians, because he is asking sometimes what are the phases produced in a DPSK for a binary stream is like this. Okay. Now we'll solve that one also. First you note down this. Now this is the data, binary data. Now this is the reference bit, means this is the reference level. Now if the reference level is 1. Now what he is asking is, what are the phase sequences produces in a different DPSK? He is asking the phase sequences. Okay. So now which operation? Exclusive NOR operation. Okay. So 1 exclusive NOR of 0. 1 exclusive NOR of 0 is 1 exclusive NOR of 0 is 0. Now again 0 exclusive NOR of 0, 1, 1 exclusive NOR of 1. Like this we have to do it generally. Okay. This is the exclusive NOR operation like this. Okay. But if instead of that, then there is one shortcut method. I will give that directly. Okay. The same operation I am explaining. Okay. So if your binary data is 0, listen carefully. If your binary data is 0, if your binary data is 0, previous level is complemented. What is the previous level? Whatever may be, it is complemented. Previous level is complemented. Binary 0, previous level, sorry. Binary 0, previous level is complemented. Binary 0, previous level is complemented. Binary 1, previous level is maintained. Binary 0, previous level is complemented. Binary 0, previous level is complemented. Binary 1, previous level is maintained. Okay. Now like this. Okay. Now binary 0 means, now what is the binary 0? Is producing a phase of 180 degrees, 0 degrees, 0 degrees, 180 degrees, 0 degrees, 0 degrees. This is the phase sequences produced. Now same question, we can do it like this. 0, 0, 1, 0, 0, 1. Now this is the binary data. This is the binary data. Now this is the reference bit. Now the reference bit is 0. Now if the reference bit is 0, now this is binary 0, previous level is complemented. Binary 0, previous level is complemented. Binary 1, previous level is maintained. Binary 0, previous level is complemented. Binary 0, previous level is complemented. Binary 1, previous level is maintained. Now binary 1 means a phase shift of 0 degrees, 180 degrees, 180 degrees, 0 degrees, 180 degrees, 180 degrees. Now like this, these are the phase sequences. Sometimes he is giving phase sequences and he is asking to find the binary data bit stream and he is giving the reference bit. Okay. Reverse also.